Morning, Anne Mary.
Good morning, Dr. McBride.
We'll wait a few minutes for the other ones to join us. Hopefully they'll be here soon. So what meeting did you have yesterday?
So we did a conference for the 8th graders about the CTE programs.
Oh,
Morning, Miss. Hi, how are you?
good.
Is the water issue solved at the campus?
Is what?
There was an issue with the water issue, something.
Oh, yes, the city of
So
Globe, I think, broke the water line.
Okay,
It's
so
fixed.
is it everything okay, back to normal?
Yeah, everything was back to normal yesterday, so we're fine.
Okay, I have a class today. I just want to make sure.
Yeah, you're good.
Okay, thank you, sir.
You're welcome.
Have a good day.
Thanks. You too. So do you have any questions on any of the homework you've been working on?
No,
Did you try and retake the other test from chapter 11?
I haven't.
Okay. You're waiting till this weekend, huh?
Yes. Did we do a lab yesterday?
We did do a lab. We started leaching. We measured the pH of sulfuric acid and water solutions. And we put some rock samples in there of malachite, azurite, and chalcopyrite. And then we're seeing which ones are able to leach out the copper. So on Monday, we'll come back and take a look at them, and it usually takes about a week for it to leach out the copper.
Yeah,
We'll go ahead and get started. And hopefully the other ones will be here shortly. So one thing we do have, I got to try and figure out again. Engineering Day is March the 2nd.
Yeah.
And didn't look like anybody from Miami registered to go to Engineering Day. I'm taking the Globe students. So I didn't know if there was, I don't know why Globe can't take you in the same van. I don't know why I can't take you in the same van. We have too many rules.
I won't be here in March.
Oh, you're gonna be gone in March anyway? Okay.
Yeah.
Oh, that's when you're heading to India?
Yes.
Okay. Guess we won't worry about that one anyway then. All right, here's the equations that we use for this chapter 12, just to review. So delta G, basically products minus reactants. That could be delta H is also products minus reactants, and entropy is products minus reactants. And then we have delta G equals enthalpy minus temperature times entropy. Remember that these need to be the same unit. So if you're in kilojoules for enthalpy, you need to put your entropy in kilojoules. And temperature always needs to be in Kelvin. Then we have delta G equals negative RT natural log of K. This is the value for R in kilojoules. It's 8.3145 joules, or times 10 to the negative 3 in kilojoules. And then we've got our little diagram here. So activation energy is from the beginning up to the top of the mountain. That's the activation energy. So if you look at these four pictures down here, which one has the highest activation energy? I'll label them A, B, C, or D.
C.
C has the highest activation energy. Which one do you think would be the most spontaneous? Would happen the easiest?
Would it be B?
And why would you say B?
Because the graph ran down to the x-axis.
So it's the lowest one, so it releases the most energy.
Mhm.
Is that one exothermic or endothermic?
It's endothermic.
So is it absorbing or releasing energy?
No, it's exothermic.
Right. This one, so A and B are both exothermic, C and D are both endothermic. So B does, it is the most exothermic, but you notice it has a very high activation energy. So even though it releases more energy, you have to climb a very high mountain to even get the reaction to happen. So A is actually the most spontaneous because it has the lowest activation energy. Or in other words, it's the easiest one that can happen because it has low activation energy. So when you're looking for spontaneous, try to find the one that has low activation energy. So of C and D, which one do you think would be the most spontaneous?
D.
Right. D would be the most spontaneous because it has the lowest activation energy. All right, let's take a look at this problem. So these are some values for cesium, which is a metal. So the freezing point of cesium is 302 Kelvin. The heat of fusion is 2.1. Boiling point is 942, and heat of vaporization is 66. So our question is, we want to calculate the entropy of fusion. So which equation would I use?
What is the second equation?
Right, so delta G equals delta H minus T delta S. Good. And where do I go from here?
Do you subtract 66 by 2.1?
Right, so this one is melting, this one is boiling. So if we want to find fusion, which is melting, we're going to be using the freezing point and the fusion values. If I
So
want
do you,
to find boiling point, then I would use these two.
so we're just finding the freezing point?
Yeah, we're trying to find the entropy of freezing.
So for delta H, it would be 2.1.
Right.
And for temperature, it would be 302.
Good. And what about delta G?
Would it be 0?
Very good. You remembered. So when we're at freezing or boiling, we're at equilibrium, it's 0. Now, how do I solve for S?
Do you divide 2.10 minus 302? Or do you convert?
Before you divide, you have to have them on different sides of the equation.
Do you take 2.10 to the other side first?
All right, so negative 2.10. All right, great.
Now you divide negative 302 to both sides.
All right, do you have your calculator?
Yes. I got 0.0069.
And the units are kilojoules per Kelvin mole. Right, that looks great. So now let's find the entropy of vaporization.
So you put 66 for delta H. The temperature is 942 Kelvin. And delta G is 0.
Great.
And you take negative 66 to the other side. And then you divide it by negative 942 Kelvin. Which is 0.07070.
0.0. All right, looks good. What if you wanted to put these in joules instead of kilojoules? What would they be?
Would you move the decimal place 3 places to the right?
Yes.
So would it be 70 joules per Kelvin move?
Correct.
And the other one, can you move the paper?
Oh, sorry.
So it will be 6.9.
Yep. So if you want it in joules, just move your decimal 3 places. All right, looks great. Not sure what happened to everybody, but they're not making it today. All right, let's take a look at another problem. So this is the one we just did. So this is the one we talked about. So why could you possibly, even though delta G is negative and it's spontaneous, why could you possibly have a very slow reaction or not get a lot of product? And the reason you wouldn't get very much product is if you had a very high activation energy, then it would take a lot of energy just to get over the mountain. And so even though it's exothermic and delta G is negative, if you have a high activation energy, it's going to be very slow. Even though it's spontaneous, it's not going to happen very likely, or as easily as if you had a low activation energy. All right, here's a good one to compare delta H's and delta S's. So spontaneous as written at all temperatures. There's our four choices. So when delta H is positive and delta H, sorry, this is, second one is S's. These are all S's. So delta H is positive and delta S is negative. What can you tell me about it? Spontaneity. So
Would it be more disordered?
okay, let's take a look at, let's just put in some numbers. So pick a number for delta H.
Two.
Right, so we're gonna put a positive 2. And pick a number for S.
-3.
Okay, so H is positive, S is negative. Morning, Jennifer.
Good morning.
So you have a positive 2 minus a negative 3. Is that going to be positive or negative answer?
Negative.
So you have a positive 2. What do you get when you have a negative times a negative?
Oh, and it would be 5.
Right. So negative 2 plus 3 would be 5. So what happens if the temperature goes up to like 5? So negative 5 times negative 3 would be,
No, 15.
and 15 plus 2 would give you,
17.
so is there, so because this is a negative times a negative is always a positive. The higher T is, the more positive delta G is going to be. But is there any way for delta G to ever be negative in this situation?
No.
Right, it's impossible because you have a positive and a positive is always going to give you a positive. So in this case, when delta H is positive and delta S is negative, it is never spontaneous. So now let's try it when delta H is positive and delta S is also positive. So instead of a negative 3, we'll make this a positive 3. And then we can try T being 1. So what's 2 minus 1 times 3?
-1.
What'd you say, Jennifer?
Wait, it'll be 2 minus 3, so that would be -1, right?
Right. So it's -1. Is that spontaneous or not spontaneous?
Spontaneous.
All right. So now let's make this a 4. So what would be 4 minus 3?
1.
it gives a positive 1. Is that spontaneous or not spontaneous?
Spontaneous.
Okay, now let's make temperature 10. Instead of 1, make it 10. What's negative 10 times 3?
Negative 30.
And negative 30 plus 4?
Negative 26.
And is that spontaneous or not spontaneous?
Spontaneous.
Mhm.
Okay, so when is this situation going to be spontaneous? At high temperature or low temperature? To make it negative, does T have to be high or low?
High.
Right, so this one we would say is spontaneous at high temperatures. Okay, let's take a look at the next one. Delta H is negative and delta S is negative, so they're both negative. Now let's make this a negative 4. So negative 4 minus 10 times 3 will give you what?
Negative 34.
Right? Good. How about if we make temperature 1, negative 4 minus 1 times 3?
Negative 7.
And so is there any way to make this a positive answer? By changing the temperature, is there any way this would ever be positive?
No.
Right, so if it can never be positive, delta G is always negative. Then when they're both negative, this is always spontaneous. And we have our last situation when delta H is negative. And delta S is positive. Oh, whoops, let's see. We had this one negative and I had S was positive in this case. So actually, this is the one that's always spontaneous. So now if one's negative, so if they're both negative, so negative 4, let's make temperature 1. So what's negative 1 times negative 3?
Negative 3.
Right, be a positive 3, and negative 4 plus 3 is,
Negative 7.
and is negative 1. Delta G is negative, so that would be spontaneous. So what happens if I make temperature 10? Negative 10 times negative 3?
30. Positive 30.
And 30 minus 4.
Positive 26.
And so positive would be non-spontaneous.
Mm-hmm.
So is this going to be spontaneous at high or low temperatures? Or I want T to be low or high for this to be spontaneous?
Low.
Right, because when it was 1, negative 1 times negative 3 was positive 3. and -4 plus 3 was -1. So it was spontaneous when temperature was low. It's non-spontaneous when temperature went up to 10. So this is spontaneous at low temperatures. So when delta H is positive, delta S has to be positive for it to be spontaneous, and that has to be at high temperatures. And when delta H is negative, it's going to be spontaneous unless you have high temperatures. So in this case, when delta S is negative, you need to keep your temperature low. So when we go to the homework question, spontaneous as written at all temperatures.
Negative delta H positive S.
Delta H is what?
Would be negative and delta S would be positive.
Okay. When is it spontaneous in reverse at all temperatures, or in other words, never spontaneous? If it's spontaneous to the right, it would be, if it's spontaneous reverse, that would be never spontaneous to the right.
Would it be delta H positive and delta S negative?
Correct. And then spontaneous above, so at high temperature.
Both would be positive.
And then spontaneous at low temperature.
Both will be negative.
Right. That's correct. See if any of those other people texted me or. So not sure what happened to the high school people today. All right, let's try another one. All right, so let's calculate this one. So delta H is negative 144.6. I'll put this on the paper so you can see it easier. Kilojoules per mole. Delta S is negative 301.2. And that's in joules per Kelvin mole. And it says the temperature is 298 Kelvin. So how do I calculate delta G?
Do you use the delta G equals delta H minus T delta S equation?
Perfect.
And delta H would be negative 144.6. temperature is 298 Kelvin. And delta S is negative 301.2. Oh, it would be 0.3012.
All right, so very good, because this one's in joules and you have to convert it into kilojoules. So great job. Negative times a negative is going to give us a positive.
I got 89.75.
89.74.
76.
All right, Kelvin's cancel there. So delta G is
Negative 54.84.
negative 54.
84.
Is this spontaneous as written or not spontaneous?
Not spontaneous.
And how do you know it's not spontaneous?
Because it's negative.
So delta G was negative 54.84. So when delta G is negative, are we spontaneous or not spontaneous?
Not spontaneous?
Other answer.
Would it be spontaneous?
Right, when delta G is negative, it's spontaneous. When delta G is positive, it's not spontaneous. So because it's negative, then that means the system is spontaneous.
I keep getting it backwards.
Yeah, gotta make sure we get those right before this weekend.
I know.
So we want negative delta G's. All right, this one's a good review. If delta G is less than 0, meaning it's negative, is K gonna be greater than 1, less than 1, or equal to 1? Or how do I fit these in?
When if K was 0, that it would, or K would be 1 if it was 0?
right, so when delta G is less than 0, so numbers that are less than 0 would be negative. What is K? And which one of these is at equilibrium, which one is spontaneous, and which one is not spontaneous?
Equilibrium should be when delta G is 0, right?
All right, so we are at equilibrium. Which one is spontaneous?
Is it the first one?
Right, so delta G is negative. We are spontaneous, which means the bottom one would be not spontaneous because it would be positive. So now K is greater than 1, less than 1, or equal to 1.
Limit.
Would the first one be greater than 1? Would the second one be equal to 1? And the last one would be less than 1.
Right, because for it to be at equilibrium, the products, you have more products than reactants. Which means it's spontaneous, so K is equal to products divided by reactants. So we want our numerator to be higher than the denominator. When the numerator is larger than the denominator, we're greater than 1. When the numerator is larger than the numerator, denominator is larger than the numerator, like 1/5, then we are less than 1. So it's a fraction. So that's K is less than 1 when it's not spontaneous. And when they're equal, products and reactants are equal, you're at equilibrium, like 5/5, 10/10, that would equal 1. All right, questions there?
No.
So I'll probably give you this type of question on your test. So Jennifer, when delta G is positive, is that spontaneous or not spontaneous?
Non-spontaneous.
Very good. Got it. All right, let's try one of these problems. So this is a calculate K problem. So delta G was negative RT natural log of K. R is equal to 8.3145 times 10 to the -3 kilojoules per mole Kelvin. And this one says delta G is 12.5. It says find K. So, oh, does it tell us the temperature in that problem? at 298 Kelvin.
Okay.
So what do I do?
So R would be negative 8.3145 times 10 to the negative third power.
All right, before I put that in, standard notation 0.00833145. Or you can use your scientific notation, whichever way you like. Times
298 Kelvin.
Now what do I do?
Times 0.08314 by 298.
Okay, tell me what you get.
2.478.
What was that number?
2.478.
Great. Next step.
Divide everything by 2.478. Five point zero four four.
5.0.
44.
And last step. Because this is natural log of K. How do I get rid of the natural log?
Do you do e to the power of x?
Yes, so we're going to take e to both sides. So e to the 5.044.
Which is 155.09.
So 155.
Yes,
So is that spontaneous or not spontaneous?
not spontaneous.
Right. And delta G was positive. So K is greater than
One.
Z. Oh, you know what? Guess what we forgot? Because that's not making sense. If delta G is positive, K should be less than 1. So can you see what we did wrong?
Wasn't that supposed to be negative
Right.
0.00?
We
Oh,
left
yeah.
out, left out the negative sign all the way through.
I wondered about that.
So take e to the negative 5.044.
Hmm. Point 0.006.
0.006.
4,
One more digit.
Sorry.
5.
So K is 0.00645. All right, and now this is less than 1, so that does show us that it is not spontaneous. That's one way you can check, because we were expecting, with delta G being positive, we were expecting this to be less than 1. When it turned out being greater than 1, we knew we made a problem, made a mistake somewhere. So don't forget your negative sign. All right, any type of questions you guys have? Want to try again?
No.
All right, how about chapter 11? Did you take the test, Jennifer?
Oh God, no.
All right, so chapter 11 test. It's still available to take 5 times. So
Okay,
this is just practice. But
I'll
I'm
get
gonna see if I can find the ones that everybody missed. So it looks like question 11 through 14. So let's take a look at those. So 11 through 14, and then 25 and 26. All right. So question 11. An aqueous solution is made by dissolving 0.455 moles in 510 grams of water. And it says calculate the molality. So do you remember the definition of molality? Moles of solute
Divided by, what's it? Kilograms?
Yes, kilograms of solvent. So the molality would be 0.455 moles divided by
I don't see your screen.
oh, sorry. That better?
yeah.
And what do I put for the kilograms of solvent?
We're gonna
510.
All right, so we've got to change grams into kilograms. So 0.510 kilograms.
zero 0.892.
Okay, correct. All right, let's see. So Anne Mary, you took the test, so let's just kind of go through yours. So 0.345 divided by 0.765 So wonder if you're off by a decimal point.
Yeah.
It probably should have been 0.45.
Yes.
All right, so remember change in temperature is equal to molality times K freezing point. So you had to look up these in your chart. And we are sodium, aqueous sodium sulfate. So aqueous, you can look up water. So the K freezing point of water is 1.86. So we should have 1.28 molality. So 1.28 times 1.86. So it looks like it should be negative 7.14. You got a 0.0239. So wonder what you probably divided instead of multiplied. That's my guess.
Yeah, I wasn't sure how to do this problem,
Okay.
but now I got it.
Let's see. So what's 1.28 times 1.86? All right, so let me go to the other screen. Looks like we're out of time, but we'll finish this one up. If I can get to the right screen. All right, so change in temperature is equal to the molality times the freezing point constant times I. And this was Na2SO4. So the molality was 1.28. The constant was 1.86 from the chart. What is I?
3.
Correct. You have 2 sodiums and 1 sulfate. So a sodium positive, another sodium positive, and a sulfate, which is -2. And then you just multiply the 3 out. And it's like it's -7.14.
Where are you getting the negative?
Okay, so the change in temperature is 7.14. Now we want to know what the freezing point is. What is the freezing point of water?
Zero degrees Celsius.
So if we change by 7.14, does that go up or down?
Down.
Right, so the new freezing point is going to be a negative 7.14. Because it always lowers the freezing point, it raises the boiling point.
Oh, right. Okay.
So your actual freezing point is negative, your change in temperature is positive, but you're changing it to a lower temperature, so the final temperature is actually going to be lower than 0, so negative 7.14.
Gotcha. Okay.
And then I'm gonna ask you finding the Van Hoff factor, so do you understand why there's I is 3 in that case? Anne Mary, does that make sense why I is 3?
Yes.
Right. Okay, that's it for today. So I'm gonna put a test up there for you. That'll be due by Sunday night. I'm not sure where everybody else is, but chapter 11, you should be able to go back and retake this test or relook at it before you take the actual test.
Yeah, I absolutely will.
Okay. All right, if you have questions, please call or text or email,
Thank you.
and we'll see you on Monday. Oh, Jennifer, did you get a chance to take any, are you on campus today at all?
I can run over there.
All right. If you can, have Selma let you in. I took the pH measurements yesterday at noon.
Okay.
There's a sheet of paper there that shows what I wrote for all of them. Want to do the same thing, just take the pH measurement. I'll give us one before the weekend.
Okay.
All right, thank you.
All right. No problem.
All right, see you on
Bye.
Monday.
All right.
Bye.
Bye.
Bye.